Let's take a look at number 20. Find the vertical and horizontal asymptotes for this for the rational function. Now for our vertical asymptote, our first step is to factor the top and factor the bottom. Factor the numerator and denominator. Step 2, cancel if possible. Step 3 is set the denominator equal to 0. And solve. So in this problem, we got 3x squared minus 3x minus 1 over x squared minus x minus 2 equals f of x. Now the top part doesn't factor. So since the top part can't factor, then there's top part can't factor. Since top part can't factor, that means the bottom part is not going to be able to cancel with anything. So I really don't need to do step 1 and step 2. But step 3 we'll jump right to. Set denominator equal to 0 and solve. So we got x squared minus x minus 2 equal to 0. Now this is the Psd method. We got x squared, x, no x, and there's no number for the x squared. With the Psd, we take the number at the end, the 2, and we ignore signs. And we're going to write down all products give us 2. Well, there's 1 times 2. In the s column, we're going to add these together. 1 plus 2 is 3. In the difference column, we'll subtract them. 2 minus 1 is 1. This isn't a very exciting problem. Now we're looking for the number in our middle term, which is the invisible 1, which is right here, which means we'll use 1 and 2 in our answers. No big surprise. Now our larger number in the p column, which is 2, will always be the same sign as the middle term, which is negative. Now if the number you circled in the s column, then it's s for same signs. If the number you circled in the difference column, it's d for different signs. One's positive, one's negative. Well, the number we circled in the difference column, so if this is negative, then the other one has to be positive. Now zero factor property says you get 0 on one side and you factor the other side. You can set each factor equal to 0. So set x plus 1 equal to 0 and x minus 2 equal to 0. And we get x equals negative 1 and x is equal to positive 2. And those are our vertical asymptotes. Well, let's talk about horizontal asymptotes. Now specifically, I'm going to refer to this as my top of my fraction, and this is the bottom of my fraction. And you remember, degree is your largest power of x. So, for horizontal asymptote, you have case 1. The degree of the top is larger. Well, if your degree of the top is larger, then there is no horizontal asymptote. Case 2, the degree of the bottom is larger. Your horizontal asymptote is always y is equal to 0. And case 3, the degrees are the same. The degree of the top is equal to the degree of the bottom. And this is best shown by an example. I could put this into words, but people get lost when I start talking about standard form, leading term, coefficient, and so forth. So let's say 5x to the third minus 1 over 2x minus 7x to the third. It's a very simple concept once you see an example. Now the degree of the top is 3, degree of the bottom is 3. Remember, degree is your largest power of x. What we do is we create a fraction by taking the number off the front of x to the largest power. So we'll put 5 here and we'll put negative 7 there. So horizontal asymptote will be y is equal to negative 5/7. Well, for this problem, degrees are the same. Degree of the top is 2, degree of the bottom is 2. So for horizontal asymptote, it's case 3, we're going to create a fraction taking the number off of the x to the largest power. So this would be 3 over 1, or we would have y is equal to 3 as our horizontal asymptote. So let's see when this one matches. X equals negative 1 and 2, negative 1 and 2, and y is equal to 3. It looks like D is in David. So 20D. Check that. 20D. And it checks.